You know that feeling when you look at your calendar and it's just a complete puzzle? You just can't solve it? Well, what if I told you there's a simple, kind of elegant trick that lets you perfectly squeeze in the absolute maximum number of meetings into a single day? Turns out there is, and it comes straight from the world of computer science. So let's dive right in.
Okay, so picture this. Your inbox is just flooded with meeting requests, and they're all for today. You obviously can't do them all, but you want to accept as many as you possibly can. So, how do you choose? Which ones do you say yes to? This isn't just a classic time management headache, you know? It's actually a famous computer science puzzle.
All right, this whole daily scheduling puzzle, it really breaks down into two separate but related challenges. The first is all about maximizing your time, your personal schedule. And the second one, that's about maximizing shared resources. And believe me, these problems show up everywhere. We're talking booking conference rooms, scheduling tasks on a computer's CPU, you name it.
So, on one hand, we've got interval scheduling. Think of this as your personal efficiency problem. How many tasks can you get done? But then on the other hand, there's interval partitioning. This is all about resource efficiency. Here, every single task has to get scheduled, so the real question is, what's the absolute minimum number of rooms or servers you need to make that happen? See? Two totally different goals, which means, you guessed it, we're going to need two totally different strategies.
All right, let's tackle that first puzzle. How do we maximize the number of tasks we can personally complete? Well, the solution lies in this really simple but super powerful idea that I like to call the finish early secret.
So what's your gut reaction here? A lot of people, maybe you too, think, hey, I'll just pick the shortest meetings first, get those quick wins out of the way. I mean, it sounds totally logical, right? But it's actually a total trap.
Just think about it. Imagine you have this really short, like 30-minute meeting scheduled smack dab in the middle of the day. If you take it, you could be blocking yourself from doing a 1-hour task in the morning and another 1-hour task in the afternoon. So by picking that one short meeting, you just cost yourself the chance to do two longer ones. And boom, that's proof. Picking the shortest task first just isn't the way to go.
Okay, so here's the real secret. You should always pick the compatible task that, wait for it, finishes earliest. Now, why does this work? It's simple, really. By freeing up your schedule as soon as you possibly can, you are maximizing the amount of time you have left for everything else. You're basically keeping all your future options wide open.
So how do we turn that simple idea into a solid algorithm? It's actually super straightforward. Step 1, and this is the magic part, you sort all the tasks by their finish time. Got that? Then you just go through that sorted list, you grab the very first task. After that, you just keep going down the list and pick the very next one that doesn't overlap. The one that starts after your last one finished. And you just repeat that. That's literally it. It's simple, it's fast, and best of all, it's mathematically proven to be the best possible solution.
So what we've just done here, well, it has a formal name, of course. It's called the interval scheduling problem. The goal is basically to find, and I love the nerdy term for this, the maximum cardinality subset, which in plain English just means finding the biggest possible group of things you can do that don't step on each other's toes.
Okay, puzzle 1 is solved. Awesome. But now for the second challenge. This time the rules have changed. We can't say no to any meetings. We have to schedule all of them, no exceptions. Our job now is to figure out the absolute bare minimum number of conference rooms we need to pull this off.
You know, the core idea here is actually really simple. Just think about it for a second. If, say at 2:30 p.m., you have 4 different meetings all happening at once, well, you're going to need 4 rooms, right? There's no way around it. And that's the whole key. The minimum number of rooms you need is just the highest number of meetings that are happening at the same time at any point during the day. All we have to do is find that moment of peak traffic, that point of maximum overlap. Computer scientists call this the depth of the intervals. And yep, this problem has a formal name too, interval partitioning. A really cool way to think about it is like a coloring problem. Imagine each meeting is a bar you have to color, and each color is the meeting room. The one simple rule is that if 2 meeting bars overlap, they can't have the same color. Our goal? Use the fewest number of colors possible to get the job done.
The algorithm for this is also what we call greedy, but there's a huge twist. First, you sort all the tasks by their start time, and you got to notice that change. It's start time this time, not finish time like before. Then, you just go through your sorted list one task at a time. For each one, you try to put it in a room that's already been used but is now free. If, and only if, all your current rooms are busy, do you go ahead and open up a brand new one. And here's a little pro tip. To do this super efficiently, you want a data structure that can tell you, like, instantly, which room is going to be free next. A min heap is the perfect tool for that job.
Okay, so now we have these two really elegant, greedy solutions. Let's switch gears a bit, put on our engineer hats, and really analyze them. Just like you would in a technical interview.
Okay, let's put these two algorithms side by side so we can really see what's what. First, look at the goals. They're complete opposites, right? One is about maximizing tasks, the other is about minimizing rooms. And the big one, the critical difference, is the sorting strategy. For scheduling, you sort by finish time. For partitioning, you sort by start time. Seriously, mixing those two up is such a common mistake in interviews, so burn that into your brain. But now look at what's the same. Their overall efficiency, what we call their time complexity.
Yep, both of these algorithms run in what's called O of n log n time. And you might be wondering why that specific number. It all comes down to the sorting. For both of them, the heaviest lift, the most time-consuming part, is that initial sort. Once everything's sorted in the right order, the rest of the work is just a single super fast trip through the list. So, let's talk about the tools you need in your toolbox for these. Sorting, that's the foundation, the absolute bedrock for both solutions. Can't do anything without it. For the simple scheduling problem, all you need after that is a basic loop. Easy peasy. But for that more complex partitioning problem, if you want to be efficient, a min heap, which you might also know as a priority queue, is going to be your best friend. It's the perfect tool for instantly knowing which room is free. Okay, let's bring this all home. How does all this theory actually help you ace that next big technical interview? Let's get into the strategy. All right, here's your cheat sheet for knocking this question out of the park. Don't just spit out the algorithm. You need to explain why picking the earliest finish time works. You need to be able to say, with confidence, that the minimum number of rooms is just the maximum overlap. Oh, and you absolutely have to mention that a min heap is the best way to keep track of room end times. A couple other bonus points. Clarify the boundary convention. Like, does a meeting ending at 10 a.m. conflict with one starting at 10 a.m.? And finally, know the difference between this and a much harder problem called weighted scheduling. Hitting these points shows you don't just know the answer, you understand the problem. If you take one thing away about why the greedy choice works, let it be this. Finishing sooner is always the best move because it leaves the most possible options open for the future. At every single step, you're making the choice that keeps your schedule as flexible as possible. It's a simple, powerful idea, and it's provably the best way to do it. So we've totally cracked the code for maximizing the sheer number of meetings. But what if one of those meetings is, I don't know, $1 million deal, and another is just a quick 5-minute coffee chat? Suddenly, not all tasks are created equal, are they? Our whole finish early strategy just completely falls apart. Solving that kind of problem requires a much more powerful technique, something called dynamic programming. But hey, that's a puzzle for another day.